Hi, Dr. Sharp. Today I'm talking to Dr. Jonathan Sharp. He is a marine biogeochemist and research scientist at the University of Washington Cooperative Institute for Climate, Ocean, and Ecosystem Studies. He is also part of the Global Observations of Biogeochemistry and Ocean Physics group at NOAA's Pacific Marine Environmental Laboratory in Seattle. What is ocean acidification?
Sure, Rob. First of all, thank you so much for having me. It's really exciting to be here to talk to you about ocean acidification.
Thank you.
So yeah, ocean acidification is the change in ocean chemistry, specifically an increase in the acidity of ocean water that's caused by carbon dioxide from fossil fuel emissions dissolving into the ocean. And so we measure ocean acidity using something called the pH scale. So the pH scale describes how acidic a substance is, and it goes from 0 at the bottom to 14 at the top, with 7 in the middle being neutral. And so the pH of normal water is right around a 7, but ocean water is actually up here at around an 8. So it's a little bit basic, a little bit above the neutral. So ocean acidification isn't actually the ocean becoming acidic, but it's actually getting closer to that acidic portion of the pH scale. So it's going down a little bit in its pH.
So 7 is good, but then 0 and the max is bad?
Yeah, so the max or the minimum 0 would be something really corrosive. The ocean will never get anywhere close to that, but that's what ocean acidification is doing. It's making ocean water more corrosive, so it causes things to dissolve in it. And good for ocean water is close to 8.
Why is it happening?
Sure. So ocean acidification is happening because of the way that carbon dioxide reacts with water when it dissolves. So carbon dioxide forms, when it dissolves into seawater, an acid called carbonic acid, and that carbonic acid can break apart or dissociate. And when it breaks apart, it adds hydrogen ions to seawater, and those are the things that decrease the pH of the seawater or increase its acidity.
How do you study this?
I study ocean acidification these days, mostly from behind my computer screen. I use data that's collected by other scientists and by small sensors on ocean robots that we can send out. But sometimes I get to study it by going out to sea and making measurements on ships in the ocean. This is an NOAA or NOAA ship called the Ronald Brown. And this is a photo I took from that ship one time when we were in some fairly rough seas in the Pacific Ocean. So it's really fun to get to go out on these research cruises and live out on the sea for months at a time and make these really cool measurements of ocean water.
It's really cool. What is your ship like?
It's a pretty big ship. It has space for 45 people, so a few more than 20 scientists and a few more than 20 crew members. And on the inside, we have laboratories where we do all of our measurements. We have the galley where we eat our meals. We have a room with a big TV in it where we can go in and watch movies when we're not working. And then we have our tiny rooms. We get little bunk beds that we sleep on. So it's an interesting way to live. It's a very small enclosed space that you're in for quite a long time. I don't know, I imagine it's almost like being on a spaceship, except we have gravity.
Do you get seasick?
I have gotten seasick once or twice, but only in pretty bad conditions. I'm normally okay, but I do know a lot of other scientists who have some issues with getting seasick, but it normally only lasts for a few days at the beginning of a research cruise, and then they work it out of their system and they're good for the rest of the time.
Ocean acidification is sometimes called climate change, its evil twin. What happens if the ocean becomes too acidic?
So I think the reason that it's sometimes called climate change's evil twin is that ocean acidification is caused by a process that is really helpful in our fight against climate change. So this shows the carbon cycle that's associated with fossil fuel emissions. So we have some fossil fuel emissions coming off and also CO2 emissions from land use change. So that's like changing forests into cities and farms. And then some of those emissions dissolve into the ocean. So that's really good because it takes carbon dioxide out of the atmosphere that would otherwise be contributing to global warming and other climate change. But it's bad because it also contributes to ocean acidification. So it's kind of like climate change's evil twin because it also causes problems of its own. And so if the oceans become too acidic, creatures that build shells and skeletons out of calcium carbonate, which is a mineral that's formed from calcium ions and carbonate ions, those creatures will be affected, like oysters and mussels, plankton and corals. And so because ocean pH, when it goes down, it impacts their ability to get carbonate ions from seawater. So if the oceans become too acidic, it will be bad for those organisms.
Poor coral reefs can't catch a break. Could this lead to a climate change tipping point?
It's hard to predict, but it's definitely possible that tipping points associated with food web dynamics could be approached. So if you're thinking in terms of a marine food web, where we have phytoplankton, which are ocean plants at the base. And then there's other things that eat those phytoplankton. And then there's bigger things that eat those things, and bigger fish that eat those fish, and all those interactions. If ocean acidification leads to the decline of one of those species at the base of that food web, that could really cause a breakdown in that community that could represent a tipping point.
Yeah. The ocean pH has dropped from 8.2 to 8.1 since the Industrial Revolution and is expected to fall by another 0.3 to 0.4 pH units by the end of the century. This does not seem like much of a change.
Yeah, it doesn't seem like that when we're thinking in terms of the pH scale, right? Just going from 8.2 to 8.1 is a pretty small change, but it actually has to do with the way that the pH scale is measured, which if you think of it like going down by one number is like an increase 10 times. So going from, say, 9 to 8 is like decreasing from 100 to 10. So little small numbers on the pH scale actually have much more of a significance than it would seem like they do. So decreasing from 8.2 to 8.1, that represents about a 30% increase in the acidity of the ocean. And decreasing then from 8.1 down to something like 7.8 or 7.7, which is projected at the end of the century, is like a 150% increase in acidity by the end of the century. So it's a big change, even though it doesn't seem like it on the pH scale.
Wow. I was reading a report about Antarctica ocean currents heading for collapse because of melting glaciers. Does this acidification affect that collapse at all?
What might happen is that changes in those currents could instead actually have an effect on ocean acidification. Around Antarctica, there's really strong currents that influence the way that water moves throughout the ocean. So for example, there's an area around Antarctica where a lot of water from deep in the ocean gets brought up to near the surface. And water that's deeper tends to be more acidic. So any changes to the amount of that deep water that's brought up to the surface, that will have an influence on ocean acidification in the surface ocean.
Yeah. How can we stop or reverse ocean acidification?
The most important thing we can do to stop ocean acidification, as you might expect, is to stop fossil fuel emissions of carbon dioxide. So that will involve investing more in clean energy technology, and policy changes to transition away from fossil fuels. Unfortunately, though, a lot of ocean acidification has already occurred. So there are also some new strategies that are being developed that could help reverse ocean acidification, at least in the surface of the ocean. And these would involve changing the chemistry of ocean water, either by adding minerals that dissolve in seawater or by using electrochemistry. And these would increase the pH of the ocean or make it less acidic. And they would also allow the ocean water to take up more carbon from the atmosphere. So these are carbon dioxide removal strategies, we call them. And so there are ones that would have that two-pronged effect of both decreasing the amount of ocean acidification and also increasing the amount of carbon the oceans can take up.
Why is no one freaking out about this? Should we be freaking out?
Maybe a little. It's definitely a problem. I think like most aspects of the climate crisis. I don't think freaking out is the best way to find solutions. I think it's really important that we educate ourselves about the problem. And it's really great that you're taking this step to educate others about ocean acidification. Being aware of it is kind of the first thing that we can do. And then once we're aware of the problem, we can support policies and politicians and do things in our life to try to solve the problem. So to try to, reduce our emissions and decrease the effects of ocean acidification.
Yeah. Is there anything kids can do to help?
Yeah, sure. So because carbon dioxide emissions are the root cause of ocean acidification, helping is as easy as finding ways to reduce your carbon footprint. So you can suggest that your family walk or bike somewhere instead of driving. You can make choices to try to conserve electricity and reduce waste in the things that you buy and use around the house. Importantly, you can tell the adults in your life and your parents to vote for people who care about the environment and who are interested in making policy changes to reduce our reliance on fossil fuels. And because of these technologies that are coming out to remove carbon dioxide from the atmosphere and lessen the impacts of ocean acidification, I think you can also try to learn about them and try to learn about the problem and how we can potentially solve it, because we'll need future climate leaders who understand the science behind climate change and ocean acidification and understand the things that we can do to try to solve them. So I think what you're doing right now is really important in terms of educating yourself about these issues.
Thank you.
Sure.
What do you wish more people knew about ocean acidification?
I wish people knew everything we just talked about. I think a lot of people have heard of ocean acidification, but maybe don't know all of the details and don't understand the processes behind it. So I really wish people knew everything about it. I wish people appreciated more the role that the ocean plays in the Earth's climate. I mean, without the ocean, we wouldn't be able to be here. It stores all of this heat from the Earth system. It contributes to precipitation that we need. It takes up carbon dioxide from the atmosphere, and it's really just a critical component of the climate system. So I wish people appreciated that more about the ocean in general. And I wish people knew that oceans are not currently acidic. They're above 7 on the pH scale. So ocean acidification is a problem, but they aren't becoming acid.
This has been a really great talk. Thanks so much for joining me today. And remember, together kids can save the world. Please like and subscribe. Thank you.
Thanks, Robert. This has been great.
Thank you. Bye.